Hello guys, this is the Rio 8.3 integrating powers of trig function. So in this case, in this section, we'll be looking at how to integrate different types of trig combination, breaking down into three types of integrals, right? So the first one we have powers of sine and cosine, where they're both the powers are positive integers. The second one is the tangent and secant. And the third one, we have three different small types, a combination of sines, cosines, or a sine and a cosine. And here we are looking at the third one, where m and n are rational, where m is not equal to n. Right, so we'll be breaking each of them down separately. All right, so the first case, we have cosine and sine, both to different powers. So within this type, we can break it down into three small types, right? A, B, and C, right? Where A is when m and n are 1, or they're both odd, or at least one of them is odd, right? For B, we have n and m both being even, and C is 1 or both equal to 1. All right, so part C is the easy one where we can just do a U substitution, and that's the one that we are most familiar with. So here we're going to spend some time looking at giving you a quick example of all three of them, A, B, and C, for the first case. All right, so let's get started. All right, so we're going to start with the first example, where we have cosine to the fifth power and sine to the second power, and this is type A. All right, so one or both odd, so we have cosine to the fifth power, which is odd. First, we want to factor out one power from the trig function that has the odd power. If both have odd power, just pick one of them and factor the one power out. So what we're going to do is we're going to factor out a cosine here, right? So we have cosine x times cosine to the fourth power times sine square. All right, that's the first step. All right, very straightforward. First step. All right, and the second step, use cosine square plus sine square equal to 1 to transform the remaining even power of the above trig function into the other trig function. All right, so this is quite annoying, or I should say a little different. So first, we don't know which one to do, right? But first, we took out the cosine, right? So, because it had odd power. So we have one cosine here. So what we're going to do is we're going to rewrite the remaining cosine in terms of sine, right? So we know that cosine square is 1 minus sine square, right? So cosine x, and then that's going to be 1 minus sine square square times sine square. All right, so I rewrote cosine to the fourth as 1 minus sine square quantity square, right? And that is step 2. Okay. Now, next, what we're going to do is we are going to perform U sub to finish the problem, right? So basically, all of these are going to be sines, and then we have a cosine right here. Okay, so let's see how we can do this. All right, so U sub, we're gonna let U be equal to sine x, and du will be cosine x dx. All right, so the du will take care of the cosine x dx, right? So this part right here, those are your dus. All right, so let's rewrite it. So we have du at the end, but let's take care of the others first. So 1 minus sine square, that's 1 minus u square square, and then u square. Right. And then the dx will just be du. Right, so now we are left with something very nice, right? It's just a polynomial, right? And now we just need to expand it. Right, so we have 1 minus 2u squared plus u to the fourth times u squared du, which is equal to u squared minus 2u to the fourth plus u to the sixth du. And then just integrate it by simple power rule, u cubed over 3 minus 2u to the fifth over 5 plus u to the 7 over 7 plus c. Right? And then we just replace all the u's back with signs, which is sine cubed x over 3 minus 2 sine to the fifth power over 5 plus sine to the seventh power over 7 plus c. Okay, and that's it. Right, so we want to, once we factor out a sine or cosine from the odd power, right? You want to replace everything else so that this is the only cosine left, or sine, depending on which question you're looking at. Okay. All right, now let's look at the second. All right, next, example 2, we have cosine to the fourth and sine square. So this would be a first type, a type B, where m and n are both even. So the idea is you just replace all the even powers using half angle identities. And then you can see here sine square is this and cosine square is that. So replace everything. All right, so let's do that. So cosine to the fourth, that's cosine square, quantity square, and sine square x. All right, so let's see. Cosine square can be written as 1/2 parentheses 1 plus cosine 2x. So that'll be 1/4 times 1 plus cosine 2x square, and sine square is 1/2 1 minus cosine 2x dx. All right. So basically what we're going to do now is FOIL out everything and then integrate it one by one. Right, so here we have 1/8, 1 plus cosine 2x square, 1 minus cosine 2x. Now, to make it a little easier, I'm going to do a little algebra on the side, and I'm just going to replace cosine 2x with w. Right, so a little multiplying polynomials on the side. 1 plus w squared times 1 minus w. All right, so this is 1 plus 2w plus w squared, 1 minus w, and that will be 1 plus 2w plus w squared minus w minus 2w squared minus w cubed. All right, so what do we have here? 1 plus w minus w squared minus w cubed. Right? I think that's it. Yeah, looks good. Okay, so let's rewrite that back into our integral. So 1/8 on the outside, and that'll just be 1 plus cosine 2x minus cosine 2x squared minus cosine cubed 2x dx. Okay. All right, so let's take a look at these four terms. Now, the first two are easy, right? And then the last two might require some work. So let's break it down into parts. Let's see. Let's call this A, B, C, and D. Okay. So part A, it's easy, right? Integral of 1 dx, that's just x. And part B, integral of cosine 2x, that's also easy. Integral of cosine is sine, so sine 2x, and then divided by 2, right? Divided by reverse chain rule. Now C, we're looking at cosine squared 2x. So here we are going to apply the double angle formula again. So this is equal to 1/2 1 plus cosine 4x, right, dx, right? And then integrate that. That would be integral of 1/2 plus 1/2 cosine 4x, which is x over 2 plus cosine, plus sine 4x over 8. All right, now last one, d. This is going to take a while, but we can still do it. Cosine 3x, oops, cosine cubed 2x. Right, so just like type A, just like the first example, we're going to factor out one of them, and then write the other one as cosine square 2x. All right, and then replace cosine square with 1 minus sine square 2x dx. And then start from there, right? So we have cosine 2x minus cosine 2x times sine square 2x. All right, so the first one is easy, right? That's just sine 2x over 2. Now this one, this cosine 2x here comes from the chain rule of sine 2x. So this will be a simple power rule, right? Sine 2x over 6. Yep, there you go. Okay, and then just put everything together and we're done. Okay, all right. So let me do a little transition here. So let's call this star. So star is equal to 1/8 times part A x plus part B sine 2x over 2 minus part C minus x over 2 minus sine 4x over 8, and then minus part D minus sine 2x over x over 2 plus sine cubed 2x over 6. Right, and then now we can cross off some of the stuff. All right, so we have 1/8 x minus x half, that's x over 2 minus sine 4x over 8 and plus sine cubed 2x over 6 plus c. Okay, so really long question, right? Because we have expanded a lot of the things from here. Oh, one thing I forgot to mention, if you are wondering how I got this 6, it comes from dividing the power 3 and also the dividing by the chain rule 2. So 3 times 2, that gives me the 6. So when you take the derivative of that, you're going to bring the 3 down. You get sine square 2x, right? Multiplied by chain rule of sine 2x, that's cosine 2x, and then times an extra 2 from the 2 here, right? So the 3 and the 2 here are going to reduce with the 6 in the denominator, right? That's how I got the 6. Okay. If you are not familiar of performing this integral without doing u sub, feel free to do u sub, right? You can let u be sine 2x and then start from there, and you'll get 6 on the bottom. All right, yeah, but that's part B. Quite long, but this is what we have to do. We have a rigorous method of performing integrals like this, right? It's a little tedious, right? Because you have to break down into a lot of parts, and then yeah, that's it. All right, so the first type with cosine and sine, and if one of them is power 1, then it's really easy. All you have to do is u sub. Right, so you want to make sure that you pick u to be the trig function without the first power. Right, so sine is our first power, so we're not going to pick u to be that. We're going to pick u to be cosine. All right, so let u be cosine x, then du is going to be negative sine x dx, right? Or negative du is sine dx, sine x dx, right? And everything will work out nicely. All right, so cosine is u, so u to the 10th power times negative du, right? And you'll see that it actually becomes very nice. We just have a simple power rule. And let's take care of the bound. So theta, pi into here, so cosine pi is negative 1. And then 0 in here, cosine 0 is 1. All right, 1 to negative 1. Right? Or we can just flip it from negative 1 to 1 and then change the sign on this, which is u to the power of 10 du. All right, and this is really easy. Negative 1 to 1, which is 1 over 11 plus 1 over 11. All right, minus negative 1 over 11, right, which is 2 over 11. And that's it, right? So the big power, don't let that scare you because we have that extra sign here. So the sign will be the result from the chain rule of cosine, right? And just need a little bit of the signs you have to worry about here. But overall, this is one of the easier one. All right, so next let's look at the other type of trig functions. All right, next let's look at the second type where we have tangent and secant. So the ideas are basically the same for the first part, right? You want to take out so that they have take out a power of each, and then apply the trig identity, and then do u sub. All right, so that's for A, and then for B, if n is even, I factor out secant square, and then replace everything else with tangent, and then that will be much easier. All right, so let's take a look at some example. All right, there we go. So first, factor out 1 power of secant, 1 power of tangent. Okay, let's do that. All right, so we have secant x tangent x, and then tangent square x secant square x. Okay, next, use tangent square equal to secant square minus 1 to transform the remaining even power of tangent into the terms of secant. All right, so remaining we have tangent square, where I replace that with secant square. All right, so let's see, we have secant x, tangent x, and then that'll be secant square minus 1 times secant square, so secant to the 4th power minus secant square. All right, and then distribute that. We get secant to the 5th power x tangent x minus secant to the 3rd power x tangent x dx. All right, next replace everything with apply u sub. So secant tangent, if tangent is power 1, then we know that the derivative of secant is secant tangent. So we can start from there. Let u be secant x, and du is secant x tangent x. All right, and then replace everything here. So we have dx, my bad. Well, what do we have here? So secant, so that will be secant to the 4th times secant tangent, right? So that will be u to the 4th minus, so secant square times secant tangent, that will be u square du, right? Like that, right? So you have to be a little careful with the u here, right? Because you still have a secant tangent that's part of du. So you want to take care of that before you apply the u here. All right, then that just gives you u to the 5th over 5 minus u cubed over 3 plus c, and then reverse sub secant to the 5th power over 5 minus secant to the 3rd power over 3 plus c. Okay, and that's it. So actually, let me elaborate a little more on what's happening from here to here. right? So here I'm rewriting this as secant to the 4th power times secant tangent, right? So that part gives you u to the 4th, and then the secant tangent x gives you the du. Okay, same thing with this one, right? That's secant square times secant tangent. All right, so you want to be a little careful about that, okay, with the power and then doing u sub. All right, example 5. Let's take a look. If n is the power of secant is even, all right, so we have secant to the 4th power. Let's just follow the steps here. All right, first factor out secant square. Okay, let's do that. Secant square, put it in the front. Everything else in here. Okay, looks good. If n is greater than 2, use secant square is equal to 1 plus tangent to transfer the remaining power of secant to be in terms of tangent x. Okay. So a little mistake, it should be greater than or equal to. All right, so let's do that. So secant square. All right, and then we're going to replace the secant in the parentheses with 1 plus tangent. So we have tangent square distributing into here. We get tangent square x plus tangent to the 4th x dx. All right, and then distribute that in. Secant square x tangent square x plus secant square x tangent to the 4th x. All right. Now keep in mind that secant square is actually the derivative of tangent. So all the secant square that you see here actually comes from the chain rule of tangent, right? So all we need to do is just do a power rule on tangent. Or if you want, let me show you again using u sub. Right, so this is something that you'll get used to when you see things like this. You can actually just integrate it without doing u sub. But for the sake of this video, and then maybe it's first time for a lot of you seeing this, let's do that. So u is tangent x, du is secant square x dx. All right. So what we have here becomes, so though this is part of du, right? So we just have u squared plus u to the 4th. Du. All right, rest is easy, right? U cubed over 3 plus u to the 5th over 5 plus c. And that's tangent, oops. Yep, tangent cubed over 3 plus tangent to the 5th over 5 plus c. Okay, not too bad, right? Pretty easy, right? Once you have everything set up, and the integral is pretty straightforward. So example 1 to 5 basically sums up almost all the techniques that we can use for integrating any trig integrals. There are some of them that cannot be done using fixed method, right? So here we're going to show you a few of them. Okay, so this is one of the first one that does not have a set method, right? If you look at in the beginning, this is, so we're looking at just tangent to the 1st power, right? So let's see. In the very beginning, where we have all the forms, right? The second one we have tangent and secant. So it actually doesn't give us any specific power, right? Power of 1, right? It's not going to work, right? Because they both require the trig sub, which means one of them has to be has a power of square. All right, so let's see what we do. So for this one, there is no set method, which makes us a little sad because we have to think about what to do, right? So this is actually, this is one of the easier one, right? So let's rewrite tangent as sine x over cosine x dx. Right now we know sine and cosine, they're derivatives of each other, right? So we have cosine in the denominator. So if there's a function that pushes cosine down and then multiply by the chain rule, which is sine, then we're done, right? And yes, we do have it. It's called ln. Right? Actually, let's do u sub, and then I'll show you what we're talking about. All right, so u is cosine x. Du will be negative sine x dx. All right, so this is, after example 6, we will be talking about some of the special integrals. Right? And then they require special method. All right, so here we go. So sine x dx, or that's negative du over u. All right, and that's negative ln of u, right? Plus c, which is negative ln of cosine x, oops, plus c. Okay, so pretty interesting, right? Tangent, who would have thought that we can do this, right? And if you want to further simplify this, right, you can put the negative sign in here, right? So we get secant x, the negative first power. Oops, not secant. Cosine x, the negative power, plus c. And negative 1 means we have to flip it. So that just becomes ln of secant plus c. Okay. Now, another one that's pretty interesting is, I think we used that earlier, but I really, oh, no, we actually didn't see that. So let's see. We have example 7. That is secant x dx. All right, and to do this, it actually requires a little trick. And the trick is you have to multiply top and both the numerator and denominator by secant x plus tangent x dx. Okay. Now, I'm actually going to stop here and let you try it out. Okay. So after you do it, you will get ln of secant x plus tangent x. Okay, so go ahead and give that a try. This is a very fun one. Okay. All right, and last but not least, we have our last case where we have combination of sines and cosines. And the main idea that we're going to use here is to rewrite the product of sine and cosine as a sum or difference, right? So you can see here on the left-hand side, we have a product, right? Sine times sine, cosine times cosine, sine times cosine. And then using the identity here, we can rewrite them as sums or differences of just sine and cosine. And that makes the integration very easy, and you just need to decide which one you're gonna use. Okay, so let's do one example together. Let's say I have sine 3x, cosine 5x dx. Okay, so they are in product, and then they have different numbers in there, so I really cannot use u sub. All right, so let's look at here. We will be using, so sine and cosine, we'll be using the last one, where m is 3 and n is 5. Okay, so that's equal to 1/2 sine of m minus n, so 3 minus 5, that's negative 2x, plus sine of m plus n, so m plus n, that's 8x. Right? Looks good. All right, and sine is actually an odd function, right? So I can bring out the negative sign. So put 1/2 out here. So we have sine 8x minus sine 2x. Yep, looks good. Dx. All right, and just integrate each one of them separately. All right, that'll be negative cosine 8x over 8 plus cosine 2x over 2 plus c. All right, and that's it. And let's clear this up a little bit, multiply the 1/2 in there. So negative 1 over 16 cosine 8x plus 1/4 cosine 2x plus c. All right, and that's it. So the third type is actually pretty easy, right? You use one of the identities and then break it up into sums or differences of sine and cosine, and just integrate each term separately. All right, so that's 8.3. And next we'll look at 8.4, which is trig substitution, and that is one popular and common type of integration. And if you're in engineering major, you will be using 8.4 a lot. All right, see you next time.